So in this particular segment, we are going to revise the concept of determinants and apply the knowledge of determinants to a method of solving simultaneous equations, and that method is called the Cramers Rule. So a determinant is basically an arrangement of numbers which is enclosed by these vertical lines, okay, and you have numbers arranged over here like 3, 2, 5 and 7. Okay, now the value, every determinant has a value, so the value of this determinant would be calculated as there are two diagonals that you will notice over here. One is the diagonal from the left top to the right bottom. So let us imagine that that particular diagonal is the significant diagonal. Okay, so what I'm going to do is I'm going to multiply the two numbers along the significant diagonal, that is 3 multiplied by 7. Then I'm going to multiply the two numbers on the other diagonal that you see, that is 2 multiplied by 5, and subtract the 2. Okay, so therefore the value of this is 3 7s are 21 minus 10 is 11. Suppose I have something like root 3, root 2, 2 root 2 and 3 root 3. Suppose I have something like this. Again, I have to take the leading diagonal. So the leading diagonal is from the top left to the right bottom. This is the leading diagonal. And therefore its value can be determined as root 3 multiplied by 3 root 3 minus, take the product of the other diagonal, that is root 2 multiplied by 2 root 2. So root 3 into root 3 is 3, 3 3s are 9, minus root 2 into root 2 is 2, 2 2s are 4. Therefore, the answer to 9 minus 4 is therefore 5. So the value of this determinant is 5. So in short, determinant is basically an invention where we arrange numbers in such a way so as to exhibit the difference between two numbers. So in short, if I have something like A, B, C and D, then this determinant is calculated as the leading diagonal is the top left and the right bottom. So it's going to be A multiplied by B, which is AB. Then the product of the other two elements, that is CD, and then you subtract the 2. And that is how you get the value of this particular determinant. Similarly, if I have something like 3 root 2 and root 5. Okay, so let's assume that the determinant is 3 root 2 root 5 and minus root 5 and root 2. Now let's be very careful. I will first multiply the elements along the diagonal. Okay, so the diagonal is 3 root 2 and root 2. So this is going to be 3 root 2 multiplied by root 2. Let's multiply the elements on the second diagonal. So it is minus root 5 multiplied by root 5. And then there has to be a negative sign in between. So you are subtracting the two answers. So root 2 into root 2 is 2. 2 3s are 6. Minus into minus is plus. And root 5 into root 5 is 5. So 6 plus 5 therefore becomes 11. So the value of this determinant is therefore 11. You need to be careful with the different terms that you have, okay, especially the signs. Let us now try to simplify something like 1.2, 0.2, minus 1.5 and minus 0.6. Okay, let us simplify this particular determinant. So again over here I am going to multiply the leading diagonal, that is 1.2 multiplied by 0.2 minus, and then I have to multiply the elements along the other diagonal, that is negative 0.6 and negative 1.5. So 1.2 into 0.2 becomes 0.24. Minus into minus is plus, plus into minus is minus, and 0.6 into 1.5 is 0.9. And therefore the answer is minus 0.66. So the best way to avoid any errors is to write the product of the two terms and then just add a minus sign in between. Now you could also have determinants for algebraic expressions. So if I have a plus b and a minus b, I could find this determinant. What I am supposed to do is again take the leading diagonal. So the leading diagonal over here is a plus b multiplied by a plus b, which is a plus b the whole square. Then take the elements along the other diagonal, which is a minus b into a minus b, which is a minus b the whole square, and subtract it. So a plus b the whole square would become a square plus 2ab plus b square, minus of a minus b the whole square would become a square minus 2ab plus b square. Now it's time to open up the bracket. So this becomes a square plus 2ab plus b square minus a square plus 2ab minus b square. Now a square minus a square cancels, b square minus b square cancels, 2ab plus 2ab is 4ab. Okay, so this is how we evaluate determinants. Now let us take a few more examples for evaluating determinants. Okay, so let's consider these examples now. We again follow the same principles irrespective of whether you have whole numbers, integers, fractions or decimals. The idea is exactly the same. Yeah. So now what we will do is, we have a determinant of 4, 3, 2, 7. So let's multiply the elements along the leading diagonal. So 4 into 7 and the other diagonal is 2 into 3, and you subtract. So 4 7s are 28 and 2 3s are 6. So 28 minus 6 is 22. This is the first determinant. Let's take the second determinant. 5 minus 2 minus 3 1. Again we multiply the leading diagonal. So 5 into 1 is 5 and negative 3 into negative 2. So let's multiply that. Negative 3 multiplied by negative 2, and I have a minus sign in between. So therefore this becomes 5. Now minus into minus is plus, and plus into minus is minus, and 3 2s are 6. So 5 minus 6 therefore becomes minus 1. So the value of this determinant therefore is minus 1. Now we could also have, let's take a look at the third determinant. The third determinant can be written as, again take the leading diagonal and multiply. So half into minus 4 by 5. Then take the other two elements and multiply, that is 3 by 4 multiplied by minus 2 by 3, and have a negative sign in between because you are subtracting. Okay, time to simplify this. So 2 and 4 get simplified by 2. So this is minus 2 by 5. Minus into plus is minus, and that into minus is plus. So this is plus. 3 cancels, and 4 and 2 also simplify by 2. So it becomes minus 2 by 5 plus half, and therefore this becomes 1 upon 10. So if you calculate the LCM, the answer will be 1 upon 10. Okay, so now let us take a few more questions based on determinants. Yes, let us consider the following set of questions and let's evaluate all these determinants. So let's look at the E1. Okay, again take the leading diagonal and multiply the two elements. So minus 4 by 7 multiplied by minus 2 by 5, and then multiply the other two elements. So that's going to be 5 multiplied by minus 6 by 35, and you add a subtraction sign in between. So now let's evaluate this. Minus into minus is plus, so that's plus 4 2s are 8, so 8 upon 35. Minus into minus is again plus, and 5 6 are 30, so 30 upon 35, and the answer is therefore 38 upon 35. This is the final answer. Okay, let me pause for a minute. If there are any questions, we could discuss them. Okay, so now what I'm going to do is I'm going to let you evaluate all the other 4 determinants, and I will also solve it on the board, and then you can check your answer. The time allotted for this particular activity is going to be roughly 6-7 minutes. Okay, I hope you were able to solve these determinants and the answers are on the board. Let us now apply the knowledge of determinants to solving simultaneous equations. The method is called the Kramers method, okay, or the Cramers rule. Let's visit that particular method. Okay, so let's understand what Kramers law says or Kramers rule says. Suppose we have two simultaneous equations. So I have a1x plus b1y is equal to c1, and I have a2x plus b2y is equal to c2. Okay, so assume that my linear equations are arranged in this form. So over here we notice that a1 and a2, these are the coefficients of x. Then b1 and b2 are the coefficients of y, and c1 and c2 are the constant terms. Okay, so now you will notice that the constant terms are always arranged on the other side of the equality side. So x and y are always arranged on one side and the constants are arranged on the opposite side. So now what we need to do is we need to find three determinants. Okay, the first determinant is the master determinant. The master determinant is calculated as a1 a2 b1 b2. Okay, so this is how the master determinant is calculated. And then we calculate, so master determinant basically is nothing but the coefficients of the x and y. So master determinant is nothing but coefficients of x and y. Then we find the determinant for x. So now please pay close attention. When I find the determinant for x, I replace the coefficients of x. When I find the determinant of x, I replace the coefficients of x by the constants. So instead of a1 and a2, I write c1 and c2, and I maintain b1 and b2. So this is the determinant for x. So in determinant for x, I have replaced the coefficients of x with the constants. Then I find the determinant for y. So let's find determinant for y. dy is going to be, now what I do is I again go to the master determinant. The coefficients of y are now replaced by the constants. So b1 and b2 are replaced by c1 and c2, and a1 and a2 remain as they are. So this is the determinant. This is the determinant for y, where you replace coefficients of y with constants. Okay, and then the value of x is calculated as determinant x divided by the master determinant, and y is calculated as determinant of y divided by the determinant. So we first calculate the master determinant using the coefficients. Then we calculate the determinant for x, which is you replace the coefficients of x in the master determinant with the constants. And determinant for y is you replace the coefficients of y with the constants. You calculate all the three determinants and then you calculate the values of x, y and z. Okay, sorry, x and y. And this idea can also be stretched for three variables. So Kramers rule is applicable even for three variables, but our scope in 10 standard is limited just to two variables. Okay, so this is how I will apply the Kramers rule. I will just pause for a minute so that you can take a look at everything, and then we will start with some examples. Okay, let us now take some simultaneous equations and solve using Cramers Rule. Okay, let us take a look at this particular question. You will notice that, okay, let's quickly summarize what we learned. We said that first, let me calculate the master determinant. Master determinant was basically the coefficients of x taken and coefficients of y taken, right? Then we said, let's calculate the determinant for x. In the determinant for x, we replace the coefficients of x by the constants. So, and the coefficients of y remain as they are. And in the determinant for y, we replace the coefficients of y by the constants, right? So this is what we did in the Cramers rule. So now I have a set of simultaneous equations here. I have arranged all the x and y terms on one side and constants on the other side. That is a requirement for applying Cramers rule. So now let's go ahead and calculate the master determinant. What is the master determinant? Master determinant is that determinant that contains the coefficients of x and y. So I have 2, 3, 3 and 2. So this is therefore equal to 2 2s are 4, and then I have 3 into 3, and I should be subtracting it. So this becomes 4 minus 9, which is minus 5. Therefore the value of my master determinant is minus 5. Now let's calculate the determinant for x. As we discussed, I will replace the coefficients of x, which is the first column, by the constant. So that's 13, 12, 3 and 2. Okay. And I will now calculate this as 13 2s are and 12 3s are, 12 3s are, and I will subtract. So this becomes 26 minus 36, and 26 minus 36 is minus 10. Let us now calculate the determinant for y. So I will have dy is equal to, as per our discussion, we will replace the constants, we will replace the coefficients of y with the constants. So 13 and 12, and the coefficients of x remain as they are. So this becomes 2 into 12 and 13 into 3 subtracted. So this becomes 24 minus 39, and 24 minus 39 is minus 15. So the determinant for y is negative 15. So the value of x is calculated as dx upon d, and the value of y is calculated as dy upon d. So dx is negative 10 upon negative 5 and negative 15 upon negative 5. So the value of x is 2 and the value of y is equal to 3. So this is how we apply the Cramers rule for solving the unknown variables. Again, I'll pause for a minute and then I will take the next question. Okay, let us take some more pair of simultaneous equations. Okay, let us consider this pair of simultaneous equations. You will notice over here that there are a few brackets that need to be opened up and some simplification has to be performed. The favorable form that we want is x and y on one side and constants on the other side. So let us go ahead and open up these brackets. So these are the original equations that have been given to us. Let us perform some simplifications now. Okay. So let's open this bracket. So 2 into x is 2x and 2 into minus 1 is minus 2 plus 3y is equal to 15. And let us shift the minus 2 to the other side. So it becomes 2x plus 3y is equal to 17. This is my first equation. Then let's take the next equation. Let's open the brackets again. 3x plus 3 into 2 is 6. Minus 5 into y is minus 5y. And minus 5 into minus 5 is plus 25 is equal to 9. So this becomes 3x minus 5y. 6 plus 25 is 31 is equal to 9, which means 3x minus 5y is equal to minus 22. This is the second equation. So now the two equations that I have in my favorable form are 2x plus 3y is equal to 17 and 3x minus 5y is equal to minus 22. So let us calculate the master determinant is 2, 3, 3 minus 5. This is the master determinant. Then I have dx. Dx is replace the coefficients of x with the constant. So 17 minus 22, 3 minus 5. That is the determinant for x. And let's find the determinant for y. Determinant for y is keep the coefficients of x as they are and replace the coefficients of y with the constants. So 17 and minus 22. So let us now calculate all these determinants. 2 into minus 5, that's minus 10. 3 3s are 9 and there is a negative sign in between. So this gives me minus 19. 17 into minus 5 is minus 85. Minus multiplication of these two terms is minus 66. So this becomes minus 85 plus 66, which is minus 19. And let's find dy. 2 into minus 22 is minus 44 minus 17 3s are 51, right? So this becomes minus 95. So I have all the three determinant values with me now. This is the master determinant, this is dx and this is dy. So now x will be given by, x is given by dx upon d and y is given by dy upon d. So dx upon d is minus 19 by minus 19 and dy upon d is minus 95 by minus 19. So the value of x is 1 and the value of y is 5. Therefore, this is how you can use Cramers rule to solve simultaneous equations. I'll again pause for say 2. Okay, let us now take the next question. So let us now solve these three questions using the Cramers rule. I hope that we don't need the arrangement of determinants anymore. We have learned how to do it. So let's look at the first question. The first check is, are the equations in the favorable form? The first one definitely is. So x plus 3y is equal to 7. That's my first equation. In the second equation, 1 is a constant which is on the left hand side. So let us now shift it to the right hand side. So the equation becomes 2x plus y is equal to minus 1. So these are the two equations that I have now, all variables on one side, constants on the other. So let's go ahead and find the master determinant. Master determinant is all coefficients of x and y. So 1, 3, 2 and 1, right? 1, 3, 2 and 1. Those are the coefficients. So then let's calculate dx. Dx would be just take away the coefficients of x and replace it with constants. So this is what I get for dx. And dy is going to be just take away the coefficients of y and replace them with constants. So 7 and minus 1, 1 and 2. So now let's calculate all the three determinants. This is 1 ones are minus 3 into 2. So this is 1 minus 6, which is minus 5. Let's calculate dx. Dx is 7 ones are 7. 3 into minus 1 is minus 3 and I have to subtract. So this becomes 7 plus 3, which is 10. And dy is 1 into minus 1, 1 into minus 1 and 7 into 2 and subtraction in between. So minus 1 minus 14 is minus 50. And therefore the value of the variable x will be calculated as dx upon d, which is 10 upon minus 5, that equals minus 2. And the value of y will be calculated as dy upon d, which is minus 15 upon minus 5, which is positive 3. Therefore, the value of x is negative 2 and the value of y is positive 3. So let me now again pause for a minute so that you can take a look at the solution. Okay, let us now solve the second question. Again, in the second question, what I notice is the arrangement of terms is not favorable for applying Cramers Rule. So let us make it favorable. So what I will do is let us take the first equation. The first equation is y equals 5x minus 10 the whole divided by 2. Let's cross multiply. So 2y is therefore equal to 5x minus 10, or I can rearrange the terms. Let me pull the 5x this side to the left hand side. So negative 5x plus 2y is equal to negative 10. This is my first equation. Then let us take a look at the second equation. It is 4x. By the way, let us switch the minus y to the left side. So it becomes plus y. And let us shift the 5 to the other side. So it becomes minus 5. So this now becomes my second equation, right? And the forms are now very much favorable for applying the Cramer's law. So let us find the master determinant. Master determinant is going to be the coefficients of x and y. The coefficients of x are negative 5 and 4. So negative 5 and 4. And coefficients of y are 2 and 1. So 2 and 1. Therefore, this becomes negative 5 into 1 is negative 5. And 2 into 4 is 8. So negative 5, negative 8 becomes negative 13. So the value of the master determinant is negative 13. Let us now calculate the value of determinant x. So determinant x will therefore now be, for determinant x, I have to take out the coefficients of x, pull them out. So negative, negative 10, negative 5 and 2, 1. and now let's calculate the value. Negative 10 into 1 is negative 10, and negative 5 into 2 is also negative 10, and then I have to subtract. So this therefore becomes 0. Yeah, minus 10 plus 10 is 0. And let us calculate dy. So if I calculate dy, when I say calculate dy, take out the values of coefficients of y, just push them out, keep the coefficients of x as they are, and replace the coefficients of y with constants, that is minus 10 and minus 5. So this becomes minus 5 into minus 5 is positive 25, 4 into negative 10 is negative 40, right? And then there is a subtraction in between. So this becomes 25 plus 40, which is 65. And the variables can therefore be now calculated as x equals dx over d, which is 0 over negative 13, that's a 0. And y is equal to 65, or rather dy over d. dy is 65 over negative 13. So positive by negative is negative, 65 by 13 is 5. Therefore, the solution to this is x equals 0, y equals minus 5. Now, every time you can actually replace this in your answer and check if your answer is correct. So, negative 5x, or rather we can substitute it here and see. If x is 0 in the first equation, you get y equals minus 10 by 2, which is minus 5. And if x is 0, 5 is equal to negative y, which also means y is negative 5. So x equals 0 and y equals negative 5 actually satisfy both the equations, and hence our solution is correct. So I'm again going to pause for a minute. Just take a look at the solution. Okay, let us now take the next question. So let's erase everything that I have here. Again, let's check if the form is favorable to us. I guess the second equation is fine. All the x and y terms are on one side, and the constant is on the other side. But the first equation doesn't seem favorable. So let's convert it into a favorable form. So 3x plus 2y. Let's push the 11 to the other side, so it becomes minus 11. And 7x minus 4y is equal to 9. So these are my two equations. Let's go and calculate the master determinant. Master determinant is 3, 7, 2 minus 4. This is my master determinant. The determinant for x is basically, I have to take out the coefficients of x. Okay, I have to take this out and replace them with the constant. So minus 11, 9 and 2 minus 4. That's the determinant for x. And determinant for y is, I have to keep the coefficients of x as they are and replace the coefficients of y with a constant. So it is minus 11 and 9. So now let's calculate all the individual determinants. So 3 into minus 4 is minus 12. 7 2s are 14, and there's a subtraction sign in between. So minus 12 minus 14 is minus 26. The second determinant, minus 11 into minus 4 is 44. And 9 2s are 18. So 44 minus 18 is positive 26. Then 3 into 9 is 27. And 7 into negative 11 is negative 77. And there is a subtraction sign in between. So this becomes 27 plus 77. 27 plus 77 is 104. and therefore the value of x is dx upon d and the value of y is dy upon d. So x is therefore equal to dx upon d is 26 upon negative 26, which is minus 1, and y is equal to dy upon d, which is minus 4. Therefore the value of x is minus 1 and the value of y is negative 4. This is the solution to my set of simultaneous equations. So again I am pausing for a minute in case there are any questions. Okay, so I hope you understood the application of Cramers Rule for solving simultaneous equations. I will now give you a few questions to solve for homework, and in the next session we can take up the some other method. These are some questions that you can solve using the Cramers Rule and the concept of determinants. I'll just play. Okay, so